So thank you everyone for joining. My name is Cody Armstrong, and of course, as you can see today, the topic is using the derived feature in Onshape. And so we're going to focus entirely on the derived feature in the Part Studio and different examples where you can use it. A short webinar for you today. So again, feel free as always to ask any questions as we're going through this. There's a questions dialog, and you go to webinar control panel. Feel free to enter in any questions, and I'll do my best to stop and address them as we're going through things. So again, using the derived feature, we're going to go over a few different examples where it applies. So let's jump into it. Now, the agenda today is real simple. We're going to introduce derived features. So if you have no experience with the derived feature, I'm going to walk you through how to use it, where to use it, walk through a few simple examples. It's not just a matter of inserting parts. You can insert sketches and planes, and there's also the idea of updating the design. And of course, the idea behind a derived feature is when you insert it, wherever you change the original, anywhere it was inserted or derived, it updates. And so we're going to cover how that update is handled. And so as I'm going through this, I have a few miscellaneous tips and tricks to go through as well that I'll just kind of put throughout the webinar. But again, short webinar, we're going to really focus on using the derived feature, how it updates, and a few examples where you might find it applicable. So let's jump in. Now, what is a derived feature? To put it short, it's the ability to insert a part, a sketch, a helix, a plane, a main connector from one Part Studio into another, into the current Part Studio. So when you select derived feature, you're saying I want to insert a part, a sketch, a helix, a plane, a main connector from another Part Studio into my current Part Studio. And there's a number of reasons that you might want to do this. I have a few examples of those in just a bit, but essentially think of any time that you've ever wanted to do that. I want to insert this part from this other tab into my current part. Maybe I'm modeling around it. Maybe I'm using it to drive other features. There's all kinds of examples I can give you of where I'd want to do something like this. Now, it's important to point out, and I'm going to get into an example later, the part, the sketch, the helix, the plane, whatever it is, doesn't necessarily have to be in the same document as where you want to reference it. So, for example, if I were building the fixture that we see there, the fixture and the part that I'm importing could be in two totally different documents. And so you can insert these things, the part, the sketch, the helix, from the same document or from a different document, what's referred to in Onshape as a linked document. I'm going to go over an example of that in just a bit. They do behave just a bit differently in how they update. And so I want to spend a bit of time on that because you do have, either the live update capabilities if you want them, or something a little bit more stable, something that will have a consistent rebuild no matter what the state of the current model is. So I'm going to go over linked documents and how to insert them as derived features, as well as how to reference from the same document. So simple explanation of what a derived feature is. Some examples where you might use a derived feature. And I think one of the most common is creating parts around other geometry. And I say imported geometry. I think that's a common scenario. Maybe I've gotten a bunch of models from another vendor, perhaps, and I need to build some frame that holds them, for example. So creating parts around imported geometry is a common, but really think of creating parts around geometry from some other tab or some other document. So anytime you need to model with a contextual relationship to other parts, that becomes, how do I import that model? And the derived feature is oftentimes the answer. An example is you'll see the screenshot of the suspension. And let's say perhaps that the shocks were standard parts that I got from a vendor as an imported model, a step file, for example. But I needed to design the shock mounts, the control arms, all the pieces that tie those shocks together. That's an excellent example where I'd use the derived feature to insert the shock into my current Part Studio, and then I can model the surrounding pieces. So creating parts around imported geometry, I think that's one very common example. I'm going to show you it in just a second. Another example I often mention with derived features is what's referred to often as a master part technique. And it's really where you have this one part that drives many different parts. And it's a modeling technique that I find very common if you have a lot of contextual relationships to one thing, one big entity. And so the master part technique, essentially you would build your master part in its own tab, and then insert that part into another tab where you'd build all the surrounding pieces. And if you build all the surrounding pieces with relationships to that master part, when you change the master part, all the surrounding pieces automatically update. So a master part technique where the base part, is in its own tab and can be changed independent of everything else. And once that change takes place, all the instances, all the places where it was derived automatically update. So master part technique, but also very similar to that workflow is a master sketch technique. And this is another common area where I have this one sketch that I want to drive several parts, maybe the entire part studio with dozens of parts, and I want it to all be driven from a single sketch. I can model that single sketch in its own environment, have it in its own space, and then insert that is a derived feature into another part studio, and then build off of it, extrude off of it, edit features, and so on. Now, the other example I want to give is starting what's referred to as bottom up and finishing top down. And so if you've come from another CAD system, you may have heard of bottom up modeling and top down modeling. And essentially, bottom up modeling means you model each part independently in its own space with no relationships whatsoever to surrounding parts. And top down is the opposite. You're building the part with relationships to surrounding pieces, surrounding components. So the bottom up and top down approach typically in many CAD systems are completely independent. You do it one or the other. With Onshape, you can start a part in its own environment, in its own part studio, build all the base features out, and then once you're ready to start building contextual relationships, the top-down modeling end of your design, you can then insert it into another part studio and add those additional features. So it gives you the ability to work in its own space and then insert that for the necessary contextual relationships that you may need. So it's a different approach. You'll find that a lot of what I'm going to cover here today it is a matter of preference. Users like to work in an individual space and have this one thing that drives everything. And they don't necessarily want to see all the various pieces that go along with it. So, a lot of what we're going to cover here today could be done using other techniques. But I think a lot of users like the idea of having this one thing that drives many, and being able to edit and change that one thing without necessarily having to look at it or see all the other pieces that go along with it. So those are just some examples. What I'd like to do is jump into things. A few questions. Has Derived Feature similar to iParts in Autodesk Inventor? Forgive me, I'm not familiar with iParts. Next question. How does this fit in with version control? We're going to go over that in just a bit, but when the parts, the sketches, the features come from other documents, they must be versioned. And once they're versioned, even if they're deleted or removed later, the original source is removed later, there's always that original instance in the inserted version. So I'm going to go over versions and linked documents in just a moment. Question: when using a derived feature, a derived sketch, how can I change its orientation? You would need to change the orientation at the sketch level, the original level. All right, so let's jump into an example. I'm going to start really simple. And what I want to show you is an example of building potentially a gasket or a frame or something around a model that you've imported. And I think this is one very common example of using the derived feature. So here I have two parasolids, a bottom and top casing. Bottom and top casing, these are two parasolids and different files that I got from a vendor, let's say. And so here's the bottom casing, here's the top casing, and of course I have my blank part studio. What I need to do is assemble these two parts and then build a flange around them. Right, so this is an excellent example where the derived feature allows me to take the two imported parts that are in two different tabs right now and bring them together in one part studio. Now, if you're not familiar with the derived feature, you'll find it in the far right of your toolbar. select Derived, browse to what you would like to derive. In this case, all I have is 2 parts. Right, so we'll start with the bottom case, let it insert, green check. Now I have my bottom case in. Do this again. Derived feature, we'll choose the top case. And so now I've inserted both parts into a single part studio. Okay, and so because we're now in this part studio, I can continue modeling. I can build my flange. I can even build it with relationships to those imported models. So here, let's sketch a circle, and we'll attach the circle to the edge here. Coincident. Right, so it's easy for me to convert entities to snap to model geometry of imported models once they're now in this one part studio. So let's select, let's do a quick convert. Right, and we'll do a simple extrude. So a basic example, but now I've built this simple flange that's tied to these 2 imported models, these 2 parts that came from another CAD system potentially. So a question that's come up, how do the 2 parts get aligned when you imported them? And another question, what is the best way to align the parts if they don't? And this is a very good question. It's a big tip that I have for you. Bear with me for just a moment. I'm going to show you this same example, but in that scenario where it doesn't align. And I'll show you what I think is the fastest solution to getting them aligned. It's important to keep in mind these parts came in aligned because they were modeled that way originally. And so essentially it imports in the way that it was modeled. I'll show you in a moment how you can position them when that doesn't happen, okay, when they don't come in the right orientation. But let's move on now. This simple example, I've imported 2 parts. You'll see 2 derived features. I've then built my extrude off of those 2 parts. I didn't add a single dimension to this flange that I've built. It's entirely constructed referencing these 2 imported models. Okay, so this is a great example where the derived feature allows me to bring the 2 things together and then build off of them. And this could be, a series of motors or pumps or things that, I need to work around, but I'm building, maybe a frame for it or a container for it of some sort. And you have several parts that you need to model around. So that's the derived feature in the case of imported geometry. Remember, the bottom casing and the top casing are essentially just parasolids that I've imported from somewhere else. I bring them together in one part studio using the derived feature, and then I'm free to create new parts off of that, right? Now, what happens if I were to move geometry? What happens if I were to make changes in the original? And so what I want to point out here is how derived features handle change. So when you make a change, let's say that I were to go into the bottom casing and the top casing and make a simple change to it. Let's do a move face. We'll do a simple offset of the outlet face here. And let's change it, make it 3/4 of an inch smaller. So I'm changing the outlet diameter on this pump housing. All right, green check. Now that's a smaller outlet. Let's do the same thing to the top casing. Again, I'll use a move face, do an offset of 3/4 inch to the outlet here. Right, so just making the diameter smaller. My point in this is when you change the original, any changes that you make to the original, when you've inserted a derived feature anywhere else in that document, they immediately update. And that's an important thing that I want to point out. Because I've inserted this part and this part into this part studio, they automatically update because they're a part of the same document. So you'll notice the outlet diameter, let's hide my part, for both parts is now updated. So anywhere you put it, it will automatically update. Also notice because my flange was referencing those edges of geometry, you'll see that this automatically updates as well. The flange automatically updates as well. Okay. Question, what if you changed only one of those parts? Would it fail? No, it would update. It would just look odd. So you create a new part studio to do the work versus working on the imported file. Yes, although that may be more of a matter of preference than anything else. I guess you could choose one of the bottom or top casings and just work in that tab. I don't know that there would be a big difference. Again, more my preference to create something blank and insert everything from there. I'm sorry, can you show once more how you imported the two parts? So we're using the derived feature to browse to and insert parts from this document, right? So I use the derived feature, I select the part, and it inserts it into this part studio. And I just did that twice to insert the bottom and top casing. Okay, so question, can you use versioning to stop updating derived for new parts? And the answer is yes. And the key to that is making sure that they're inserting from a different document, a linked document. I'm going to show you an example of this in just a bit, but it allows you to version control this so that it does not immediately update. It allows the user to choose when to update. And so that's an important thing with regards to derived feature I want to focus on today is, in this example, it automatically updates, but that's because it's all in one document. But if I did not want these to automatically update, I could put this housing, for example, or these housings in separate documents, version them, and then insert them into this document. And then I do not have to worry about automatic updates. It's then a linked document. I'm going to show you an example of that, so don't worry if it confuses you at this moment. Can the derived body be isolated to avoid automatic updates? Yes, I'm going to show you an example of that with a different document in just a bit. But keep in mind, if everything's in the same document, it will automatically update. And that's the default behavior. If it's in a different document, it's version controlled, it does not. Okay? And I'll show you an example in just a bit. All right, so simple example of the derived feature. All I did was take two parasolids from, maybe an email that I got. I imported them into a document, put them together in the same part studio, and now I can model my flange, my frame, whatever it is that I'm building around those imported models. Now, this could be imported models. This could be models that you've just built on their own. There's nothing specific to imported geometry here. Maybe you just built a bottom and top casing on their own, and now you need to bring them together to model around them. So again, a lot of this is a matter of preference. So a lot of users like to start a part on its own and then later finish it top down. Right. So simple example of the derived feature where I'm inserting parts. Now I mentioned before, there's also this concept of a master sketch technique where instead of inserting a part, you can actually insert sketches and planes, for example. Now I mentioned there's even other things. You can insert a helix, a make connector. So there's lots of things you can insert as derived features. It's not just parts. And the example I like to give, and I think a very common one is, oftentimes I get asked by a user, what if I wanted one sketch that I have on its own, and I want it to drive a whole bunch of different things, maybe different parts, different things within the part, their location, and so on. And it's a very common technique. I've often heard it referred to as a master sketch technique, where this one sketch kind of drives everything. And so this is an example of that master sketch technique, where essentially I have a single sketch and actually a plane to go with it. So I have this master sketch and the plane, and what I'm constructing here is a clamp. And this master sketch drives essentially the entire design, right? The clamp is essentially these two arms with a series of pins and a threaded rod that joins them. So essentially everything is going to be driven by this one sketch. And the reason I do it this way is because then I can drive a whole bunch of part locations and how everything updates by a single sketch. If I make a change to this one sketch, it potentially changes it in many, many different parts. So this is the example. Again, the only thing I have in this part is a single sketch and a plane. I can then go to another part. This is a blank part studio, just getting started, and use the derived feature to insert that sketch and plane. Now, the question came up earlier, how do I position it? How do I rotate it and things like that? You want to make sure that it's in the orientation before you position. It's going to come in the default orientation that it was originally created in. Now, in my case, I've got this master sketch and plane inserted as derived one. Now, I can take this one sketch and start using it to construct real features. It behaves just like a sketch in any other part studio. In the original part studio was created, I can start to select pieces of the sketch and extrude them, for example. So at this point, you really wouldn't be able to tell the difference between a sketch in this document versus a sketch I inserted as a derived feature. The main thing is now, as I start to construct all these parts, they're all driven by the other tab. And it allows me to open up that other tab and change everything without necessarily looking at all the individual pieces. Okay. So I can say, okay, let's do a second extrusion. We'll create our second arm. All right. Green, check OK. And now I've created two arms from that single sketch. So I have two parts. Let's take this one step further. I'm going to create a new sketch, and I want to sketch entities but attach them to the derived feature. So, for instance, if I draw this sketch, you can see I can constrain it to the previous sketch entity, my derived feature. So again, it behaves no differently than as if the sketch were a part of this document, or this tab, I should say. So we created two simple circles. We constrained them relative to imported sketches. All right, so now I'm attaching new sketches to imported sketches. Do this one more time. Different sketch plane. A few more circles. Right, I'm adding constraints relative to them. So here's a concentric constraint between the previous sketch and this current sketch. We'll set these two to equal. And so now I can take these new sketches that are being driven by my inserted sketch and extrude them. Right? Not only can I extrude them, I can reference my imported plane as well for my up to face in condition. Right? So now I'm extruding them and I'm saying up to face, and I'm referencing that plane that we inserted a second ago, right, with the derived feature. So again, I'm referencing a sketch that we inserted with the derived, and I'm using the plane that we inserted as the up to face reference. Right, green check. We'll do a simple Boolean subtract, and subtract the arms from the pins. Okay. And now I can mirror the pins, again using the same imported or derived plane that we referenced a moment ago. Right? So we can use something like a mirror. We'll do a part mirror here. These parts. Mirror them about, again, the derived plane, the plane that we inserted with the derived feature, and we can merge them with the originals. Okay. So real quickly, I've inserted a simple sketch and plane, and now I've constructed 6 parts, all referencing that one sketch and one plane. And you may ask, well, what's the benefit of this? Now, if I go back here, this drives everything. So because I'm now controlling everything with this one sketch, I can go in, edit, and make a dimension change, for example. Let's change the length of each arm to 2. Remember, everything's in one document, so it's going to instantly update. I go back, everything instantly updates. Okay. And it's not just that. Let's go to the left plane here. I can also change the plane location in the original. So let's do a quick measurement from end to end here. So face to face, we have a measurement of 1 inch. And let's say that I needed to make that length, I need the gap between these clamp arms bigger. I need to change the offset of this plane. I go back to my original, right? I edit the plane. You can see it's set to 0.375. Let's change it to 0.5. So I'm adding slightly more offset to the plane. Once I do that, when I go back, that will impact not just the original extrude, but also the mirror feature that we referenced in the other parts video. Right? So now if I take that same measurement, let's go from face. Right? So we'll go from face to face. 1.25, we added a 1/4 inch just by offsetting that plane that represents the center of our clamp. So again, I'm inserting a sketch, I'm inserting a plane as a derived feature. I can go back to the tab where I constructed those things, and I have this one place where I can make all my changes. Okay, so it's a something I've had a lot of users ask for. I think it's a preference, a technique that I think a lot of people prefer, and I definitely wanted to point that out. Now, again, because everything's contained within this one document, once I make a change to the original sketch, anything that was derived off of it will automatically update, okay, because everything's in the same document. All right, so questions. Forgive me, I'm a little bit behind here. Can you insert a variable as a defined feature? You can, not as its own feature, but you can insert a sketch using variables as a derived feature, yes. What happens if you modify the derived sketch? Everything updates. It's important to keep in mind you cannot modify the sketch from where it's been derived into. So in this case, you'll see derived 1. I cannot right-click and edit a sketch here. I can edit the feature and define, redefine perhaps what I want to reference, but you do not edit the sketch here. You go back to the original, and that's where you'll do any modifications. If you modify the derived sketch, then try to modify the original in a different way. Again, only one place where you can modify the original, and that is at the original. Anywhere where it's derived, you cannot change the original. Can we have the master sketch open in one instance of a browser and a 3D part open in another? Absolutely. This might be a clean way of working on multiple monitors without showing or hiding. Remember, you can right-click any tab and say open in new browser tab. And then I can disconnect that tab and move it to a different monitor if I wanted. That's part of the benefits of being a cloud-based application, something that runs in a browser. It behaves just like browser tabs. So you can disconnect this tab and drag it to another monitor. You can right-click any one of the tabs in your document and say open as a new browser tab, and that would allow you to have the master sketch and the finished model up at the same time, and they would live update as you make changes. How do you add clearance or interference between the parts you're making there? As modeled, they're all line to line, and that is correct. In the example I showed you just a moment ago, everything is the Boolean does a perfect subtract of the pins, but there is an option for an offset in the Boolean. And you can say offset in individual directions. So I could say, give me 10 thousandths offset between the two cylindrical faces if I wanted to. Or maybe I wanted a gap distance from the top of the face to the end of the face. So you can apply individual offsets to give you a gap or to give you what we refer to often as like a press fit, where it's a few thousandths over, for example. So offset is an option when you're doing those Boolean operations. Will the attempt to delete the original part give a warning that it's used as a derived feature somewhere? Does the source know its children? In the example I'm showing here, I could right-click and switch to that document. So it doesn't know where it's coming from. I could switch to it. In the case of deleting, if I were to delete the master sketch in this example, this derived feature would fail, which would cause subsequent failures. And that's kind of the double-edged sword, so to speak, of the live updating approach. If the original source gets removed, the feature would, of course, fail. Now, you could go back in your history and restore. You could, so it's not like a permanent thing, but it is a live update in that sense. But if you use what we're going to show in just a moment, a linked document where it's linked to a version and not all within the same document, it would not matter. You could delete the original and the linked document would always remain intact. So if you're concerned about that, I would definitely recommend putting whatever you want to insert into its own document and versioning it. And then you never have to worry about changes to the original breaking, so to speak, where it's updated. What is version controlled? We're going to go over that in just a bit. Are you planning on a webinar purely on Boolean functions? I am not, but that's definitely a good idea. So thank you for the tip. That may be something we add in the future. All right, so moving on, I've talked about inserting a part using the derived feature, actually inserting a few parts. We've discussed this master sketch technique where a single sketch drives many different parts and it's in its own tab. right? So you can insert sketches, you can insert planes as derived features. But the question came up earlier, what if I need to move parts around and they don't necessarily come in with this correct orientation? And so let's jump back just real quickly here. I have an example. Let's jump back to our slides real quickly. So this is probably the most common question I get with regards to transform. I use the derived feature, and they come in and they're not oriented the right way. Right? And as I mentioned before, they come in the orientation that they were modeled in. But if they weren't modeled with respect to each other, that's not very helpful to you. So the question ends up, how do I position parts that are derived? I've inserted these parts. They're not in the correct orientation. How do I position them? And the short answer is what we refer to as a command called transform. They need to be moved using transform. Now, you can use transform in a simple way like an X, Y, and Z. I can say go up an X and over an Y and down an Z, for instance, and give certain values. You can transform by line, where I sketch a line and that constructs how I want the transform to behave. I think for most users, and most of the time, transform using make connectors makes the most sense. And I'm going to show you an example of this. This is probably the approach I would recommend if you're trying to place parts in a very specific way. So transform using make connectors is the short answer to how do you position parts that are derived. Now, the example I have for this, same example as before. But in this case, they will not come in cleanly as mated pieces. So let's walk through it. I'm going to create a new part studio. So a new blank part, just like we had before. And if you look at the originals, this is the same parts, but notice their orientation with respect to the origin. If I select the origin, if I look at the default planes, I can see the part is clearly not over the origin. It was modeled in some other fashion. And the same goes for the top casing. It's shifted quite a ways off of it. So when I go back to my part studio, when you initially insert them as derived features, they're going to look odd. And that's just because of their position with respect to the origin. So here's the first feature, right? Here's the first part. We'll do this again. Insert the top case. Again, both of these were not modeled in any orientation with respect to each other, so they come in an odd fashion, right? And so now it's my goal to bring these together in the same way that I had them a moment ago when they just snapped in. And that is the transform with make connectors. Now, I do want to take a moment to point this out. It's under the transform command. You'll see transform by make connectors. The key thing there is, of course, like the name implies, you need two make connectors. And this is by far the easiest way to align parts. As I mentioned before, there's options for XYZ and line. But in complicated scenarios or just scenarios where I want to take this and attach it to this, make connectors seem to be the easiest approach. Now, another tip that I have is I would recommend inserting the make connectors at the original tabs for the imported models in my example. And this is just so that if I insert these parts anywhere else, they also come with that make connector. It just makes it easier to do this again anywhere else. So I'm going to go back to the original imported models. I'll select the make connector command from the toolbar. And I want to attach a make connector. Think of the make connector as an attachment point. I want to select an attachment point on this top casing, which is right at the center of that circle. Right? So I want that point to attach. I'll go ahead and select OK. Right? So now I've got a make connector in the top casing. I'll go to the bottom casing and I'll insert its attachment point. So where I want that make connector to attach to. Right? So I'll select make connector. Right? Again, attachment point here. Green check. And now I've inserted two make connectors. When I go back to my part studio, I can then reference them in the transform command. Right? So now when I go back to transform, I can say transform by make connector. The part I want to transform is the top casing, and I want to transform from this make connector to this make connector. Now, initially, it may not necessarily come in the right orientation. So much like mating a part in an assembly, you'll see mine's upside down, but it's easy to flip the primary axis or just flip the make connector in the original part, and it will come in in the correct orientation. Now I use the green check, and now I have my flange or my top and bottom casing in the same or in the correct orientation, I should say. So that is a very important one. A question that's come up, and I think it's a very common one: can you then transform them to the origin? And the answer is yes. And it's something personally that I would do just for cleanliness sake. I don't know that there's a specific reason to, but it definitely looks better when the part is centered over the origin of the part studio. And in that case, you could do a simple transform. You could place a make connector with the origin, for example, and accomplish the same thing. But again, a big tip, and that's for those anytime you're trying to use a derived feature and it doesn't come in the right orientation, you'll need to use something like a transform to position it. If it's just a simple up or down a certain mount, you can just use a transform by XYZ. But if it's, I need to rotate a certain amount and go over, and it's very much like mating a part in assembly, use transform with mate connectors. Add a few mate connectors, and then it's easy to position the parts. And now you can go on and build, in my case, my flange very easily, the same way I would in the example I showed you a moment ago. Okay. So a big tip, again, is the transform with mate connectors. Makes it easy to apply. And again, when you're adding those mate connectors, think of them as attachment points. Where do you want, part A to attach to part B? Question. Is it possible to copy a sketch or object with edit capabilities without the parent-child relationship? You can copy a part and paste it. You can duplicate a part, you can copy and paste a part, and in that case, it does not have any relationship whatsoever to the original. So I could right-click a part and say copy to clipboard and paste it, and then there's no relationship whatsoever between those. You might call it a dumb copy, so to speak. It's not derived, so it doesn't update. So that's something I might try if I did not want them to update. The clamp build using the derived feature seems identical to the same master sketch contained within a single part. One of the advantages of using a derived feature to import a sketch versus just a part studio that contains the master sketch in a midplane. And this is a very good question. So just to repeat that one more time, forgive me, the clamp build using derived feature seems identical to the same master sketch approach entirely contained within a single part studio, and that is true. What are the advantages of using a derived feature to import a sketch versus just a part studio that contains the master sketch? And I mentioned this earlier, and this is very much a matter of preference and technique. There is no huge advantage to having everything in its own tab, or having a master sketch in its own tab, as opposed to just being a tab at the top of the current part studio. I will say that the people that like that approach like the isolated environment, the ability to look at a sketch and see nothing else in the feature list, nothing else in terms of rebuilding parts and so on. In many situations, it's strictly a matter of preference. Can you transform the origin? Absolutely. Is the one concentric connector sufficient to hold the part in the correct orientation, or is another required? One transform. Remember, there's no concept of degrees of freedom in a part studio, so one transform will position the part. That's all you need. There's no movement, so to speak. Can you transform without making mate connectors ahead of time? The way you assemble, let's perform a fixed pre-mate without pre-mating. Yes, you cannot do that as of today. You can do transforms along XYZ or along a line or some kind of a reference, but you cannot grab and drag or use mate-like behavior where it's automatically selecting given mate connectors. So that is not yet available. You do need to make connectors ahead of time, at least as one of the easiest approaches. Can a derived feature be scaled? Yes, and you can modify features that are inserted as derived. So I can add a hole to this, or I can add a boss to this. And so I mentioned before, you may like building the part by itself for a certain amount of time, building a set of base features out, and then inserting it and finishing it, adding the necessary holes or parts that are tied to other things in a derived instance in another part studio. Okay. Why is there parting line surface in the example of this? To be honest, I don't know. I think there's drafted surface throughout this, and this may be a drafted part where that being the parting line for that surface. can you union derived elements? I do not see any reason. This may be a bad example. Yeah, so now those are joined. So the answer is yes, and you can do that with you can do extruded cuts, removes. You can add features to it, so it is not untouchable, so to speak. You can make changes to the derived feature, the model inserted in the derived feature downstream. And so now I can add another feature that ties it to a mount that I perhaps created or something. So lots of different things you can do with derived. It's not untouchable. Now, it's important to keep in mind if you want to edit what's here, you'll need to go back to the original. But if you want to add to it, you can do that right here in wherever it's been derived, wherever it's been inserted. All right, so moving on, that was transform with make connectors, a very important part of positioning parts that you've maybe imported or parts that you've modeled in other tabs, for example. Now, the question has come up a few times now, well, what if I don't want things live updating? Or what if I want to insert a derived feature from another document, not from the current document? And there is an important distinction between the two. And I want to set that up for you. So just bear with me for a moment. When we talk about inserting a part, a sketch, a feature, or excuse me, a plane, for example, from another document into the current document, that it's what's referred to as a linked document. And in Onshape, if you insert any part or assembly from one document into another, it's what's referred to as linked. And the reason that's important is our linked documents behavior is dependent on a version. So one of the first steps, one of the most important things that you need to do when you insert a derived feature is you're going to need to create a version first. And so that's step number one. Whatever you want to insert into another document as derived needs to be versioned. And the reason for this is once it's inserted as a version, it does not automatically update. You could delete the original part, the part could change, and it does not impact immediately the anywhere it was inserted. Right? And so you choose when you want to update, and that's an important distinction. Okay? So make sure to create a version in the document that you want to insert. Then when you go to derived feature, it's just a matter of instead of using current document, there's a button there for browse documents. And I'll show you in just a second. Then you can browse through any and essentially, browse to any document that you have and insert any part, sketch, so on, that's in that document. So essentially, it allows you to browse, just like browsing from the documents page. What's important, and I think the key takeaway is when you do it this way, when it's inserted from another document, it does not automatically update. Everything I've shown you up to this point automatically updated, and that's because it was all within one document. So a new version is needed if you want to push an update. And that's an important thing to remember. So if I decided to make a change and I do want to push an update to anywhere where that was inserted, I would need to create a new version. Right? And so then I would update linked documents, and then anywhere where I've referenced it, I can update. So the reason for this is for stability. And the reason I mention that is because it's often come up, well, I don't want the original source constantly changing, breaking my dependent design. And that's the idea behind using a linked document and derived features. So a question that's come up, can you push from any version previously created? So when you insert a derived feature, you can specify what version you want to insert. And you can update to a specific version as well. So you don't necessarily have to update to the latest. You can, if there's 5 versions, you could choose which one you wanted to update to. Now, again, the primary reason for this is stability. So it's kind of a double-edged sword. Some people like the automatic updating behavior, but the automatic updating could leave you in a scenario where your linked or your derived feature, I should say, is broken, right? Because the original is broken, anywhere it was automatically referenced is broken. And so it's kind of, like as I mentioned, a double-edged sword. The idea behind linked documents is it's stable because it's dependent on a version, and a version never changes. Even if you delete the original document, it will never change. And so you know that building around that is stable. And you have the option to update if a new version is created, but you don't have to. Okay? All right, so let's jump into an example of this. Now, the example I have is very similar to what we've been working with. It's a fixture plate for that upper housing that I was talking about a moment ago. So here I've got a fixture plate, and I've got a separate upper housing model, right? And they're in two different documents. Now, this fixture plate I use in a number of different places, right? And maybe I've built this variation for the upper housing, but the reality is that once I build this thing, I do not want it automatically updating when I make a change to the fixture plate. Maybe I make many different changes to this fixture plate, and I only want a certain few to be passed over to the upper housing when I insert it. So they're in two different documents right now. And it's important to point out, when I go to my derived feature, let's say that I want to insert this fixture plate. I want to browse to the derived feature. The button to browse documents is up here at the top. By default, it assumes that you want to use the current workspace and you want the live updating behavior that we've been showing up to this point. But in my case, I actually want to browse documents. So I select browse documents. I can get essentially the same list you see on the documents page. So I can filter, I can search. In my case, I'll go to my documents. We'll choose our fixture plate. Now what you'll notice is it gives me a message. You need to create a version in the fixture plate to move on. And I haven't yet created a version. So as I mentioned before, that's really step one here. You won't be able to do this until that version is created. So let's go back. Go to the fixture plate. We'll create a version. We'll just call it V1, right? Click create. I've now created a snapshot of this document. And the reason that's important is it can never change. And so if I insert it into any other document, I know that I don't have to worry about it dynamically changing. So now when I go back, use derived feature, browse document, we'll browse to that same fixture plate. I can use V1. You'll see V1 referenced here. Okay. Now you can select which version. I mentioned that before. There's an icon here. If I had 2 or 3 or 10 versions to choose from, I could specify which version I want. Right. In my case, real simple. I want to insert the fixture as such. Right. Green check. Now I've inserted the derived feature into my Part Studio. Right. Notice the link icon. Right, that's kind of the visual cue that this is a derived feature that's linked to another document. Right, so this we again didn't see before because everything we've done was in the same document. Now the big advantage to this, the reason that this is important, is now I can continue making changes to the fixture plate, and it does not update live in the upper housing. Right, so let's make a quick change to this. I'll do a create selection, and I want to choose a series of holes, and I want to grab all of the holes for the clamps. Right, we'll select the patterns. You'll see it'll automatically select all the holes that match. I'll click add selection, and now I've selected all those holes at once, and let's do an offset. Right, offset face. We want to offset, let's say 0.25. So I want to make the hole diameters for each of the clamps 1/4 of an inch smaller. All right. So a simple change, green check. Maybe I go through and make a few other changes. For the sake of time, I'm going to move on. Maybe if I wanted to make a simple change to materials, or I want to, change hole diameters, or maybe I need to add something as a feature to this. It's important to keep in mind as I'm changing this, maybe I'm over here in the upper housing also making changes. It does not dynamically update. So notice that I made the change in the fixture plate, but these holes remain the same. And that's because they're linked to version 1 of that fixture plate. Okay? Now, it's important to point out, what if I do want them to change? What if I do want them to update? And in that case, you need to create a new version in the linked document. So in my case, I've got the fixture plate. I can create a new version. We'll just call this V2. Now, anywhere where that was inserted, anywhere where that was referenced, you're going to see a little visual cue in the feature list. And the idea behind it is to, hey, flag you, this is potentially a newer version is available, right? So a little visual cue on the link symbol, a little blue circle here, and that's your visual cue that a change has happened in the link document and a new version was created. And so again, you have an option. You don't have to update. So I can leave things as they are right now. Maybe I've already inserted the ports and I've built this fixture and I don't need to update it. Or you can right click and update. Right? So I update link document. That will allow me to choose what do I want to update to. So I can update to the latest, which is going to be the default, and it says update to version 2, but I can also do a selective update, and I can specify, maybe if I had 4 or 5 versions, no, I want to update to version 4, not version 5. So you can specify which version you want to update to. In this case, update to latest is going to be the default in my scenario here. Makes the most sense. I hit update all, and it will push the update to the holes, the colors, all those things to this inserted document. Okay. So just keep in mind, you do have the ability to update if you decide you want to make a change. Okay. Now, the question has often come up, well, what if I didn't want that? What if I wanted to undo? And remember, it's important you have your history here as essentially an audit trail of everything that you've done, and you can go back to any point in it and restore. Okay? Yeah, technically, you could go back and I guess change version and point back to the old version and accomplish the same thing, but this is just an easy way. Go back in your history, point to before the update, and restore. Yep. So that was it. Can you revert to a previous version of the derived part? If you just wanted to go back to where it was, undo would allow you to do that. History would allow you to do that. You could also edit the derived feature and specify, so if there is a change, you can update with a different version. You don't necessarily have to update with the latest. Okay, so that is linked documents. And the important thing I wanted to point out there is when you do it that way, the fixture plate is in a separate document than the upper housing, so 2 different documents. It's important to keep in mind versions, creating a version. And the key thing there is it will not automatically update. So as I continue to make changes to this upper housing where I inserted it will not necessarily dynamically update. I can version it and then force an update, but it's not automatic. Okay? And that's the big difference between having everything in one document and having everything in different multiple documents. And the key thing, just keep in mind, make sure to create versions for any changes that you may want to push to the derived instances. Okay. Questions. Colors applied to faces or features. In the newest release of Onshape, can you make those colors show up in drawings so that they can be used to group services for specifications and characteristics? I think the short answer is no, you cannot apply colors specifically to a face or a feature as of today. And you cannot show them as colored in the drawings themselves. So I think the answer is no. All right, so moving on, that really is what I had planned for you here today. Just real quickly, jumping back to the slides again. I know this is an important step that I want to kind of reiterate here. Forgive me. If you're working with linked documents, make sure to create a version. And that's the easy step that's missed often. Create a version, and then you can insert that anywhere you want. Using a derived feature, you can insert it into assemblies. You can do all kinds of things as long as there's that version established. Just use the browse documents. So in the derived feature, you have browse documents. The important thing here is if you do not want it to dynamically update, this does not do that. And I think that's what a lot of users ask for. So when you insert a derived feature that's linked to another document, it does not automatically update. You would need to create a new version and then right-click Update Linked Document to get it to update. And this is done deliberately so that you have a stable version that you can always build off of. So that's really what I had planned for you. I am going to stick around and answer any questions. I see that there are a few questions there, so bear with me. But real quickly, going forward, if you're just getting started with Onshape, we really encourage you to try Onshape in your professional environment and let us know what you think. Invite others, share, give us your feedback. There's a feedback mechanism under the help menu. We've tried to make it very easy for you to give us your feedback. So please, we encourage you, let us know, any feedback that you have. Also, if you're interested in meeting local users or maybe interested in establishing a user group, we'd love to hear from you. We'd love to help you set things up. So that's what I had planned. I know there are a few questions, so again, bear with me. I will stick around and answer those, but that's it, everyone. Thank you and have a good day.